everybody, and welcome to lesson 5.1, where we're going to look at exponential functions here today. So back in chapter 3, we're talking about linear models, where we'd have a slope and a y-intercept. So in this lesson here, we are going to talk about exponential models, how things grow by, instead of a constant rate, by a percentage. So we first kind of start with some terms that we want you to make sure that you know. So the first couple terms are, at least the first term is very scientific, and it's called half-life. So if you've had a chemistry class, you may have heard about this. But a half-life is basically when only half of the amount remains over a period of time. So what happens a lot of times is we can measure how old something is or when something dies, because we know how long it takes for the material to decay and how much carbon is left in the material. So it's actually kind of really cool. The second definition up there is called doubling time. So this is more when we're talking about money, and it's simply about the amount of time it takes for an amount to double. Lots of times when we're investing, we want to see how long does it take for our money to double, say from $100 to $200. So the main function that we're going to look at here today is called the exponential function. Y equals a plus b to the x power. So in this equation, we do have an a and a b, but they do mean something a little bit different. A is still the starting value, so that is pretty much the same as that as a linear equation. But our b is not a slope anymore. It is either going to be a growth rate or a decay rate. So as you can see over here, as I talk about growth and decay rate here, you're either going to go 1 plus the rate as a decimal or 1 minus the rate as a decimal. So knowing whatever that interest rate is or what percentage it's going up or down, you're going to add or subtract it from 1 depending on if it's going up or down. The last two words is a review, going back to chapter 1, how we talked about these words when we were talking about, recursive definitions and geometric. Well, a geometric can actually be written as an exponential function. So we kind of review these two words, appreciate and depreciate. Remember that depreciate is when something goes down in value. Appreciate is when something goes up in value. So what's really cool about these exponential functions, when something is growing, what's going to happen is it's not going to be linear anymore. It's going to curve up and it's going to go potentially really fast. Or if it decays, the graph's going to start at a high point and it's going to curve down and get smaller and smaller and smaller. Okay? So let's take a look at how we go about doing these formulas. Okay, so this is a great question. It goes back a little bit in time, but still nonetheless kind of a cool question to do. It says, how many cars will there be in China in the year 2020? Wow, it's this year. What a great question. So here we have some data collected on the left. You can see the year 2000 to 2007 and number of cars in millions. So it says, make a scatter plot of this data on your calculator using a nice window. So what I'm going to do is I'm going to, instead of entering in the years, okay, I'm going to enter in the numbers 0 through 7. You want to do that because, remember, this is kind of like your x value, and you really don't want an exponent to be 2,000 because you're taking a number to the 2,000 power. Your calculator is going to more than likely error out. Hence why we use smaller numbers to correspond to them. And then these numbers right here, I'm going to enter in list 2. So again, just to remember how to enter in data in our calculator, we simply go stat, edit. Of course, I got a bunch of data in here, so I'm just going to kind of highlight the lists and clear them out. So you can see I'm clearing them out right now. And so now I'm going to start typing in these values. So in the first list, I'm going from 0 all the way up to 7. So I have the numbers 0 through 7. In the second list, I have the numbers that correspond to it. So in the year 2000, 3.7. Then it went 4.7, 6 point, whoops, Don't like it when it does that to me. Sometimes it doesn't take my enters, so 6.2, 8.5, and it did it again to me. Wow, calculator's being a little hard on me here. Maybe just gotta go a little bit slower, make sure it takes it. Sorry about that. So we keep on going and enter these values in. Almost there, 18.2 and 23.2. So I do double check just to make sure everything's looking good. So now, again, to make a scatter plot, what we're gonna do is we're gonna hit second, and we're gonna hit the y equals button. So I go second y equals, I'm gonna select number 1, and then my X list needs to say list 1, and my Y list needs to say list 2. So I select the scatter plot. The type needs to be that one, okay, right there first. So list 1 and list 2. Okay, so now I can go ahead and hit graph. Of course, it doesn't show up nice. So after all that fun, I need to hit zoom, and then I have to hit the number 9. So I go zoom, 9, and it fits it right in there. So you can start to see how you got a curve here going, and it looks like it's growing exponentially. So now we want to get this exponential equation. So to get the exponential equation on your calculator, just like linear regression, we go stat, and we go right arrow. So as I hit stat and right arrow, but now we want the exponential one. So you gotta scroll down, and I believe the exponential one is 0. So it is 0. It says EXP for exponential reg. So I select that one, make sure it's on list 1 and list 2, go ahead and calculate, and it's going to give me my A and B value there. So let's go out 3 decimal places. So my A value is 3.6895, really rounds to 90, and then my B value 1.303, so times 1.303 to the x power. Okay? So now I have this equation. So now, question 3 says, according to your equation, what percent is the car ownership growing each year? So if we think about the percentage, 1 plus R, that's equaling this 0.1030. So if I subtract the 1, okay, R is equaling 0.303. So what that means, so I move that decimal over 2 spots, it's increasing at a rate of 30.3%. Wow, that's growing quickly. So now the question becomes, according to our equation then, how many cars should there be in China in the year 2020? So if I think about this here, 2020 should correspond to the number 20. So I'm going to let x equal 20 in my equation, and I'm going to solve for y. So let's do that. Y equals 3.690 times 1.303 to the, not 30th, 20th power. So 3.690. It helps if it takes 0.690 times 1.303. Use your caret key to the 20th power. And we hit enter. Wow! So y hat's going to equal 734, roughly, since we're talking 37 million cars. Wow. Now you might be saying, Mr. Varts, that's just insane. Well, let's think about the population of China a little bit here. Population of China is well over 1 billion people. My guess is it's about 1.2, 1.3 billion people. So 1 in every 2 people are owning a car. That still might be a little extreme. My guess is that might be a little bit high. But my guess is there's probably a few 100 million. All right, so let's go on to the next page. All right, so what I did here was I copied over kind of the exponential formula, what A means and what B means as a growth rate or decay rate to help me do a couple of these problems. All right, so on number 1 here it says most cars depreciate as they get older. That's true. Suppose a Honda Civic is worth $18,000 and loses 10% of its value each year. What is its value after 2 years? So to find this, we could just use this exponential equation. Y equals A is the starting value. Well, its initial value was 18,000. It depreciates by 10%. So I'm using this one right here. Okay? So I'm going 1 minus the 10%, 0.10, and we want to know its value after 2 years. The x in our case is representing how long, or years. So to the second power. Okay? So we go ahead and calculate this out. So 18,000 parentheses 1 minus 0.10 close parentheses, raise it to the second power, and we get the car's value after 2 years will be $14,580. All right, so then it says, when is this car worth half its initial value? So we want to figure out x when y equals half of 18,000 is 9,000. So now this is tricky because we don't know how to solve for x yet. And we won't learn how to do that until 5.6. So how we're going to try to do it is this way. We're going to go to our y equals and enter in our exponential equation. 18,000 parentheses 1 minus 0.1, close parentheses, and raise it to the x power. So now what I'm going to do is I'm going to go to the table, and I'm going to look at my x value where my car, so you can actually see here in my table after the second year, see how much it was worth. I want to see when it gets between 9 where 9,000 falls. And I can see it fall somewhere between years 6 and 7. So I can just say here, somewhere between year 6 and 7. All right, let's take a look at the second one. So the second one says your diamond ring appreciates 5% per year. Okay? Its initial value was $2,000 when your beloved gave it to you. What is the value after 5 years? So the key thing here is appreciates. So you know that this one is going up in value. So I can start by saying y equals the initial value or starting value is 2,000. So now I'm going 1 plus the interest rate, and now I want to know its value after 5 years. So, new equation. So I'm going to exit out here. So I start at 2,000. Now I want to go 1 plus 0.05 and raise it to the 5th power. So I get $2,552.56. So now, just like I did the last one, I want to know when is it worth twice its value. So I want to know when is it worth $4,000. Okay? So I'm going to enter this equation in my y equals on my calc. So I'm going to go back to my y equals. I'm going to delete out this equation, and I'm going to put in the 2,000. Whoops, need another 0. Helps. 1 plus 0.05 raised to the x power. So now I'm going to look at my table, and I want to see when does my diamond ring, when will it approximately be worth over 4,000? So when I look at my calculator, it's somewhere between year 14 and 15. So you can see there 39.59 and then 41.57. All right, that takes care of the notes for 5.1. You can go ahead and start working on your CFU worksheet.